Suggest a suitable physical situation for each of the following graphs. So let us analyze the following graphs and let us suggest what is the physical situation. So let me take the first graph itself. Suppose if I draw a coordinate axis with this one, oops. So this graph is given like that. Now I will draw according to the given lines. So this is something is on x-axis and here it is in negative x-axis, and somewhere here if I take, and this is as this is, so it is given different segments. Suppose this is displacement versus time. Now let us try to describe this graph, position versus time. So whenever you look position versus time, so look for slope. So slope gives that the object velocity, because slope is nothing but x by t, that is nothing but velocity, or we can say that the velocity dv equal to dx by dt, the rate of change of velocity. So if we able to understand velocity, then we can able to describe at least the motion of the object. Now, so in this segment, if we can divide this as p, q, r, s, t and k. So like this different segments. Now the slope of this part, PQ part, slope equal to 0, and the time here also equal to 0. When time equal to 0 and slope equal to 0, what we can say that the object is at rest, it's not moving at all, and displacement is also 0. The three parts at here, slope means nothing but velocity, and time equal to 0, the distance is also equal to 0. So from PQ portion, so PQ portion gives the object is at rest, and it's also a straight line. So finally I got understand here this is at rest. Now here you can see, after that when time is increases, now from Q to R, from Q to R the slope is positive, because when time is increasing the position also changes. The slope is positive, it means it is having the velocity is positive, and there is a displacement, displacement is also increasing and time is also increasing. So from the QR portion, so this portion when time is increasing and position also changing, so velocity is also positive, or if you can see the slope is remains constant, so we can say that velocity is constant. So it means the object is moving with constant velocity. So if we can write that from P to Q at rest, from Q to R moving with constant velocity. So likely if you can see from R to S, from R to S, the object position is decreasing from R to S. So in this portion R to S, position is decreasing and time is increasing. When time is increasing, position is decreasing, what happens? Velocity is decreases. So in this Q to R, the object is still moving, but velocity is decreasing. So Q to R, slope is negative means object velocity decreasing constantly. Now from S to T, if you can see from the S to T, here the displacement is negative in the segment. So here displacement is negative. Yeah, from S to T the displacement is negative. Suppose if I draw a line, so here it is coming the negative displacement axis. So here it is minus x. The displacement is negative. So displacement is negative means the object is moving backward. The object is moving backward. So that is the meaning of displacement is negative. So if we can mention that here, the object is moving backward. And displacement is negative, and in this situation time is also increasing. So when the displacement is negative, obviously velocity is also negatives. Now from the last segment, from T to K. So again from the T to K, again it is rest. Sorry, T to K. Now the displacement is constant. When time is increasing, it means the object is at rest. Now we can say from all these points, from P to Q object is at rest, and Q to R moving with constant velocity, and Q to R is moving constant velocity. Then after R to S the velocity is decreases. Maybe the object is hitting, so the velocity of the object decreases very spontaneously. And S to T, again the object is moving backward. And T to K, so let me write this properly. So to T to K, the object is again appearing at rest. So combine this all situation. So if you combine this all situation, suppose if you are having a ball, or if you are throwing a ball, so this is the ball. So from P to Q, ball is at rest, and after some force is applied on the ball. So from Q to R, ball is moving positively with the help of some external force. Then after from S to R, the ball is hit by some object. Maybe it hits on the wall. So that's the reason the ball velocity decreases. Hit on the wall, therefore velocity decreases. After hitting on the wall, the ball changes direction. So from S to T, ball change its direction. So then after from T to K, the ball comes to rest. So this is something like that. The given graph gives the information about the slopes and the possible physical situation. So that could be the one of the possible physical situation. Now let's see the B graph. So B graph is velocity versus time, and different lines are there. So let me take the B situation. So let me draw quickly. So this is my velocity versus time graph. Now if I take a straight lines, so this is one of the straight line, and after, so this line velocity is decreasing. Yeah, So like that. So when time increases, the velocity decreases. So this is something, the graph is given on the time axis. So this is everything on the time axis. It means I need to move the time axis on there. Yeah, let me take out this. Now the graph is plotted between velocity versus time. Now you see the situation. The first thing I understood that when time is increasing, when time is increasing, the velocity of the object is decreasing, and that decreasing is not a constant decreasing. So if it is constant decreasing, we need to represent just a continuous line which is falling down from velocity to time. So like this we need to represent. But here there is something gap is there. So this situation comes when if we draw a ball from certain height. Suppose if I draw the position versus time graph. So this is the position versus time graph for the given velocity versus time graph. A dropping object, a bouncing ball which is dropped from certain height. So this is the displacement versus time graph. If this is the displacement versus time graph, see the ball is dropped from certain height at point A, then after it hit on the floor at point B. So this is the displacement, it is falling. After hit on the floor, what happens? The ball velocity increases, again decreases, the displacement comes C to D, again increases, again decreases. So like that, the position versus time graph. So if this is the position versus time graph, the velocity versus time graph of this situation. So this is the exact the graph. So this is the velocity versus time graph. So I can write that the velocity versus time graph represents the velocity versus time graph represents the motion of a ball. The motion of a ball thrown up with some thrown and it hits the ground. And hits the ground and gets rebounced. And gets rebounded. So the velocity versus time graph, motion of a ball thrown with the initial velocity. Oh, if you see the first line carefully, the first line, at here the velocity is maximum. So the ball is having maximum velocity, then here the ball having minimum velocity at 0. Now from minimum velocity, the ball velocity is from 0 to negative. It means it is increasing. So this situation, this line represents the object thrown up. So here I add a sentence, an object thrown up. So initially it is thrown up. An object thrown up and it hits the ground, and it hits the ground and gets rebounces. So something like that. Suppose if the ball at here, it is thrown up, again it falls on the ground, again it falls, again it falls, again it falls. So like that, its velocity, its position changes. So this is ground. So this is represents the displacement versus time graph, x versus t. And to this represents the velocity versus time graph for this present situation. And this graph, what I have taken as a diagram, so this represents a ball dropped. A ball dropped certain height. So there is a too much difference is there when a ball is thrown up and when ball is dropped, just dropped. So the given velocity versus time graph represents a situation that, so object is thrown up initially, then after it is falling and hitting on the floor, so gradually its velocity decreases. So coming to the third graph. So this is the acceleration versus time. So the graph is represent something, a sharp lines. So as time increases, the acceleration constant up to there. Then after here also acceleration is constant. But sudden acceleration increases from here to there. The acceleration is peak. So acceleration versus time. So this is the situation. A ball is moving from, suppose if I take from here A to B. So an object moving with constant acceleration. So from A to B, constant acceleration. Constant acceleration. And from B to C, if we can observe, from B to this is point C. From B to C, something is happening. All of a sudden, the object acceleration increases, and same time object acceleration decreases. So this situation comes in the collisions. So from B to C, acceleration is increased and acceleration is also decreased all of a sudden at a moment. So this happens some collision. So that is the particular case to collision. So from after that one, if I take from C to D, again acceleration is constant. So this is situation, one of the situations. Suppose if a ball, a cricket ball, so the motion of uniformly moving cricket ball, uniformly moving cricket ball, turn back by hitting with the bat. So that is the corresponding situation for the given acceleration versus time graph. The most probable suitable situation, the motion of uniformly moving cricket ball and after hitting with a bat and it is turning back. So these three graphs are represent different particular situations. So this is how we need to analyze the given graph corresponding by observing its displacement, corresponding slopes and velocity increasing or decreasing and change in acceleration.